So for this last video, we're going to look at a slightly more complex example, which is going to use several of the techniques that we've seen in the lecture. So the problem statement is basically you have two circles, as you can see on the figure, C1 and C2, and these circles touch in a common point, which I'll call S. And we also know that at the point where they meet, they have a tangent line. So that line is basically running and touching both circles C1 and C2. And we're asked to find the equation for that line given the equations of the circle. So there's not a lot that we know other than these equations, so we'll have to proceed in several steps. And as a more or less interesting etymological aside, you have these touching circles right here. So that's also called in mathematical terms osculating circles. And osculating is a word that comes from Latin, that means kissing. So you can picture this as two circles that are kissing in a single point S. So for the first step, let's try and find the coordinates of that point S. So we're going to find S. And in order to do that, we'll use our two equations. So we know that S has to satisfy both equation 1 and equation 2. So we know that if S has coordinates x and y, then x squared plus y squared minus 6x minus 12y plus 37 is equal to 0, and x squared plus y squared minus 6y plus 7 is also equal to 0. So these two together determine the point. This was 1, this was 2. Now, if we take equation 1 minus equation 2, then we get that minus 6x minus 12y plus 37 plus 7y, so the x squared and the x squared drop out, y squared and the y squared also cancel, and I'm writing down just the terms that are left over, so 6y minus 7 is equal to 0. And if you clean it up a little bit, you'll get that y is equal to 5 minus x. So if I know x, this will tell me y, but I don't know x yet. So to find the x coordinate, let's call this 3, and let's substitute 3 into either one of these two equations. It'll give you the same result, but let's take the easier one. Let's substitute into 2, and then what we get is x squared plus 5 minus x squared minus 6 times 5 minus x plus 7 is equal to 0. And if you clean that up a little bit, you'll get 2x squared minus 4x plus 2 is equal to 0. And if you look at that for a bit, you can solve this quadratic equation, and you find that this is 2 times x minus 1 squared equal to 0. So the solution of this is x is equal to 1. So you can do it either way, solve the quadratic equation or see this product, but you should find x is equal to 1. And from x is equal to 1, we also know from our equation 3 that y is equal to 4. So that tells us that our point S has coordinates 1, 4. And note we had a quadratic equation here, but we only find one solution. And that's an important check because we know these two circles, they meet in one point only. And generally speaking, two circles can intersect in 0, 1, or 2 points. So here you want to make sure that you find only 1 point, otherwise there was a mistake. So that gives us S, great. Let's continue and let's try to compute one of the centers of the circle. So I'm going to take C2, because it's the easier equation, it has less terms. So I'm going to find the center of C2, and let's call that point P. And just to run slightly ahead, why are we interested in the center? Because if we draw the line PS, then that line is going to be perpendicular to the line that we want to find. So that's how perpendicularity is going to make an appearance, but we're not there yet. So to find the center of C2, we use the technique that we saw earlier. So we take x squared plus y squared minus 6y plus 7 is equal to 0. And we try to make squares out of this. So x squared is already a square, and then y squared minus 6y to make a square of that. We have to add 9 here and subtract that here. And then this expression becomes y minus 3 squared. And so we get that x squared plus y minus 3 squared is equal to 2. And from that we get that the center P has coordinates 0 and 3. So my figure is a little bit off. That point P has to be on the y-axis, but that's okay. We don't really need to figure at this point. So now let's continue on the next slide, and let's quickly remake this figure. So we had our C2 with the point P. We had our C1 here. Our tangent line like so, our point S here, and we left off saying that the line PS is perpendicular to the line L that we're trying to find. So for the third step, let's find the slope of the line L. So first of all, we know that L is perpendicular to the line through P and S. And so let's find the slope of that line. So let's call the slope of that line MPS, and we know the formula for the slope. It's the difference of the y coordinates divided by the difference of the x coordinates. So here we know that P had coordinates 0, 3, S had coordinates 1, 4. So the slope is 4 minus 3 divided by 1 minus 0, and so that is equal to 1. And now we know that the slope of the line L times the slope of the line PS, this is slope line L, and this is slope of the line through PS, that has to be equal to minus 1. So in other words, the slope of the line L is minus 1 over MPS. That's minus 1 over 1, or just minus 1. Okay, that's great, because now we have the slope of the line, and we know that the point S is on the line. So now we can find L given slope ML is equal to minus 1 and point S with coordinates 1, 4 on the line L. So for that now we can do things a little bit pedestrian. we know y is going to be the slope times x plus the intercept, or just x plus the intercept. And now we can substitute the point S to find the slope, the intercept, sorry. And so we get 4 is equal to 1 plus q, or in other words, q is equal to 3. And putting all of these things together then tells me for the tangent line that I have y is equal to, oh, and sorry, I made a mistake here. Let me correct it. The slope here is minus 1. So this is minus x, minus 1 here, and the equation, this then becomes 5. So I get minus x plus 5. And that's my final answer for the line. So you see 4 steps, 4 different formulas that we had to use, and this is quite relevant and representative for the problems on the exam and also in the exercise.